The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Welcome back to the Electronics Inside, the show where we tear down tools, toys and appliances just to find out what's inside. I'm David, and in today's episode we're going to be tearing down a couple of hotel-style door locks. I think this is going to be pretty challenging. First of all, because it's not an area that I'm particularly expert in, so please correct me in the comments if I make any mistakes, getting any names for anything wrong. I will do my best. I've done research and I've worked with some things like this in the past. The other thing is I've got to be slightly security conscious. I don't particularly want to go around blurting about security flaws and issues with any particular make and model of lock to then find out that this gets splashed all over the internet and a facility that might still use these gets broken into because of me. That would be bad, and I don't want that to happen. So if there's something I leave out, it could be deliberate. Don't hate me. Anyway, let's start by having a very brief look at one of these, and we'll go over some of the basics so we know what we're looking at later on. I'm going to go with this one, and I think I'm going to tear that one down first, but I'm going to use this one as my example. Okay, so I think the basics you've got, this is the inside or the secure side of the door, and you can see that using this handle actually opens the door. Of course, in this locked state, nothing happens on the outside door. Of course, these are both older technology, so they use swipe cards. Obviously, you can imagine the newer ones would be proximity, RFID, NFC, that kind of thing. So in this one, you magnetic card in there and it would actuate. And this may seem obvious, but they have a key backup. So if batteries fail, if power fails, you can still open the door. It's something that people often overlook when they're trying to specify fail safe and fail secure, two totally different things, and they have different requirements about them as well. So on the inside, we've got a thumb turn that operates the deadbolt. Obviously, handle again, and on the secure side, you've got a battery pack on this model. We'll come back to that in a bit more detail later. Now, again, this is where I get a bit iffy. Deadbolt, sometimes called a dead latch. I would have just called it the latch. Now this one has got an assist, this little tongue here. Now this helps because of the sort of the shape and the profile of this latch. It's designed to be very secure and penetrates a long way into the keep, which is the metal plate that goes on the door frame. And this will need some assistance because if you can imagine the keep hitting there, it's going to be very hard to close that door. So it has this extra little tongue to assist it going all the way in, which is not to be confused with an anti-slip tongue, I think they're called, which if you imagine on the back of the latch, there's often a little sort of semicircular bit. And the idea of those is that when the door is closed, the latch then pops back out into the keep, fully extends, but the keep isn't positioned to hold that tongue back. And what that means is you then can't forcibly push this back. And that's to stop you sort of sliding something in and pushing that back. It's an extra security thing. And I am not overly sure what this little bit is. It seems to come out if you push it the wrong way. I think that's actually supposed to be fulfilling the same role as our anti-slip tongue. And if I press that in, yeah, sure enough, I can no longer depress that. So if you imagine in a door frame, I then wouldn't be able to attack the door by pressing something in because that's now locked. Excellent. So general terms, handles, non-secure side, handle secure side, and the mortise set in the middle. So with that kind of covered, I'm going to put this lock to one side and we'll come back to it. And we'll look at this one first. These are heavy and they are greasy, so apologies. By the end of this video, I'm expecting another one of messy hands. So again, this one, deadbolt, assisted latch, ooh, and yeah, anti-slip. And that mortise and the inside, we'll get those all apart now. Okay, so on the secure side of the door, there's really nothing special. It's just a handle on a spring and a knob on the plate. That's it, no electronics, nothing fun for us to look at there at all. And similarly, Our Mortise kit is absolutely boring. I mean, there's nothing in here electronic or exciting at all. And the extent that you could use that with manual door locks and it would be absolutely fine. Now, this is where we start to get into the interesting stuff. Now, this one is slightly different to the other, where you'd put your card in like that, and again, it's magnetic stripe. And at the bottom, we've got this little port. I'm kind of assuming this is going to be a battery port, because it would make sense if all the electronics are on the outside, that the battery will be here somewhere, and it makes sense that you would want to be able to change that in case it fails. There you go. Now, these are both examples of offline door access control door locks. And it's interesting, in a whole facility scenario, you tend to find a very deliberate mixture of offline and online. And from experience, you tend to design online card readers on the perimeter, and that's particularly pertinent with more modern cards, things that use sort of the newer MyFair contactless type specifications, because you can use cards as what's called a virtual network, which is an awesome idea. Basically, because you can read and write data to this can contain more information than just what is known to me. If there are 100 people with access to a building and everybody has to go through an online card reader, they can write information to my card about someone else's card. So if you imagine I'm person 1 and person 10 for whatever reason has been banned, but they're already in the building, they can only dynamically update the online card readers. So I swipe through the front door, or person 10 swipes through the front door, their card gets banned. But they can also write on my card that person 10's card has been banned. So if person 10 is already in the building, when I swipe in through the online card reader, my card gets updated saying, next time you swipe through an offline card reader, tell the offline card reader to ban person 10. And that way you can use the whole infrastructure as a network without any actual networking. It's an awesome idea, and I hope I did a good job of explaining it. I'm not sure I did. So there we go, with the last screw out, we are finally in and can see the mechanism. So we've obviously got this All right. Calm yourself. So you see the door running up here doesn't latch. I've got a motor, of all things, I hadn't expected that. And also you've got a micro switch here which interfaces with the deadbolt. So the deadbolt, I'm going to go out on a limb here and guess when the deadbolt is activated, it would stop the handle working. So there's no point in letting somebody hear the door work and fumble about with that if the deadbolt's already in, because you're never getting in anyway. So that makes complete sense to me that you would want some electronic feedback to be able to deactivate the card reader when the deadbolt's in. A lot of words in there, sorry. So when the card is activated and appropriately on, you can see this little worm gear will drive the motor, be driven by the motor, and that starts to lift up this little sort of path and engages that metal dog in with the handle. So now all of a sudden you turn the handle and everything fires out at you. I mean, obviously it's a risk of what I do here, but you can see how that would then open the door. So yeah, the motor then has to run all the way back to disengage that. So it's motorized. So let's get all the lock assembly apart. Nothing too electronic in here. There's this little plastic guide that runs along that nylon path that actually creates the secure and insecure side. You've got a magnetic strip reader at the top, obviously. Micro switch for disabling the electronics when your deadlock is in place. Cute little motor, nothing special about it at all. I mean, based on the fact there's 3 cells, it's probably a 4.5 volt or 5 volt, 6 volt even motor. It doesn't have to really do very much. The other thing I will say in the favour of motors is, unlike a solenoid, you can't defeat it with a magnet. I mean, you could hold an AC current next to it and actually try and or physically override the commutator, but seems unlikely to work. Oh look, there we go. A lot of metal in these, and not a lot of silicon. I have to admit, I've never actually seen a magnetic stripe card reader. That was a tiny little spring holding that in place. What's interesting is that on here there's like 3 little positions that you could put the strip reader into. So yeah, you could use different types of card, I guess. That head is so much like a tape reader head, but I guess it's only reading 1 track of data from start to finish. So you could have different track doors configured to do different tracks of data. So if you imagine the entire track is about 10 millimeters wide-ish, I guess, then you don't actually need the whole strip of data. I forget what it is, like 80 bytes, is it, on a magnetic strip? So yeah, you can have different doors around your hotel, like suited keys, reading different segments of data on the card. So there's not a ton on here. Beautiful conformal coating on the board. You've got a couple of small ICs. One of these is bound to be a motor controller. Based on its position, I'd guess that one, it's going to be a microcontroller. It's interesting that the firmware sticker on here is actually under the conformal coating, so might actually have a chance at getting that sticker off, revealing under the conformal coating what it is. CY6C27443 245X1 14256239475505. If that means anything to you, shout. That's likely to be a microcontroller of some kind, and you've got other passives for power regulation, motor control, and possibly an op-amp to amplify the signal off the magnetic strip, because that's going to be incredibly low current and power. So that's going to need amplifying before you can make a usable signal out of it. I wouldn't be surprised if there was a dedicated chip for amplification and signal output off of a magnetic strip. So that's one door. And the reason I wanted to do that one first is because that one's less interesting. Mechanical, everything's in the front, which from a security point of view is less desirable. Now, granted, I don't think you're likely to pry that off the door too easily, but the electronics really sit behind this plastic piece. They don't actually go behind the metal. So they're not inaccessible, but having all of your electronics on the non-secure side of the door is very undesirable because it leaves them open to people doing naughty things to them. Yes, it makes it easier in case of failure, but then you get the good stuff, like this one. And you can instantly tell this is going to be more interesting because the Mortise has got wires going to it. Don't know if they're feedback or actuation yet, but we will find out. The power supply's on the inside, along with, as far as I can tell, more of the electronics. Let's get this one into bits and have more of a look. Right, so on the front, you've got the manual override key here, which goes to this at the bottom. We'll check out exactly how that works later. Handle that actuates on the shaft, but doesn't actually open anything. So yeah, there's definitely got to be some actuation in the Mortise this time. Take that keyway out. There we go, there's some of that famous dirt I was worried about. And you'll also notice that the deadbolt shaft doesn't actually protrude out of the Mortise, so nothing connects the front. And the front is plugged in to the back with a lead. So I'm guessing this is card reader and sends data back to the secure side of the door, which would be the right way to engineer a product like this. You do not want all of your card reading stuff on the non-secure side and then just send like 12 volt, 5 volt signals or normally open, normally closed signals to motors and actuators, because that's exactly, you see it in Hollywood films all the time, somebody poking around with a card reader and all of a sudden the door unlocks. Shouldn't physically be possible. If you fiddle around with a card reader, you break the card reader. The intelligence on the back end, which would actually open the door, should be on the secure side where no one can get to it. And that's in every single film you can think of, right back as far as War Games, I think. That was a good film. When did that come out? I could spend months of teardowns just doing products in War Games. That would be amazing. Yeah, if anyone knows where I can get hold of a Whopper supercomputer, let me know. Okay, so again, you've got this kind of movable card reader. So this one actually sits into slots, and I can pull that out and move those along in those guides, but it's only reading a very finite amount of the card. So the rest of this board is a series of LEDs and the 3 cores for the card reader, so that's all you get. So the raw data from the card is being passed back to the secure side where it's then doing any processing. And that will then send signals back to the front, which tells it yes, no, and what LED to illuminate. So again, let's disconnect the Mortise and put that to one side. Let's keep going with this. Oh, beautiful. Okay, so this, wow, that's super interesting. So this manual lock at the bottom of the outside engages with this big at the bottom here through this slot. And as you turn that key, it turns a cam, presses a switch, which I'm guessing actually engages this handle to make it effective and do anything, and then moves the handle. So yeah, that micro switch activates the handle to actually do anything. So that switch there bypasses the security. So if you ever needed to, wait, this is exactly what I said I wasn't going to be doing. Disregard that. Metal gears too. Ooh, fancy. So you've got two pairs. I'm guessing you've got a 5-volt ground or something similar. This again had 4 AA, so it's running on 6 volts. So it could be 6-volt and ground, and then 2 signals, I would guess. And then you've obviously got your second micro switch down here. And again, beautifully conformally coated grease. Lovely. I had ignored until now the deadlock. And the deadlock is almost, when it's out of Mortise, completely free rotating. But you see on the bottom here, you've got a little glass vial, and it's a little leaf switch, a little micro switch. And I'm gonna guess that shiny bit in that shaft is magnetic. Yep, so that quarter turn makes or breaks that switch just to tell it whether it's deadlocked or not. That's cool, I like that. More metal work for the collection. And yeah, interesting that this has got an edge connector, presumably for programming. I mean, the conformal coating on here is just so much of it. It's tons. And it looks great, but it must have been expensive. But I don't know how old these are. And I imagine this one's older, because when you sort of compare the amount of ICs on here to this, when they effectively do the same job, you kind of imagine that, yeah, they would have condensed this down to a single microcontroller, and all that functionality is available here. Anyway, there's the electronics that does all the thinking and the talking. Let's try our best to have a look inside this Mortise, because this is where all the action happens. So in here, we at least have to have some way of actuating when that handle turn is going to work and when it's not. So let's take a look. There we go. A very similar mechanism. So again, you've got that little motor and a worm gear. Drive that manually, see what it does. Yeah, just engages that little dog. So without it, I can freely turn that. Ooh, freely turn that. But as soon as that motor spins and engages, of course I'm never going to turn that with my fingers, but then you can see it will actuate the door until I pull it all apart. That was inevitable, really. So we know that at least one of those signals is going. Oh no, because I kind of assumed that they were going to be plain voltage and signal, but of course there's no reason it could have been black and red just for motor actuate, and it could have been something like an H bridge to be able to drive it both ways. So let's get this apart and find out what the 2 white signals do. Whatever that is. So there you go. Black and red drive the motor, and there is a micro switch as an end stop just to let the mechanism know when the handle's released and back in its normal position. Yeah, clever solution. For actuation of short movement, I wouldn't go to a motor for reliability, but clearly it's an industrial enough solution that it's workable. But I don't feel like I'm qualified to make any sort of sweeping statements about the quality or the electronics in these, and it's really hard to tell with the quality of the conformal coat on this, even what most of it is. But equally, it's been super interesting to see this application of low-level electronics and where they can be used in a security installation. I hope you found it interesting. If you have, head over to the Element 14 community and let me know. And while you're there, why not let me know if you've got any ideas for teardowns that you'd like to see. But in the meantime, thanks for watching. I'll see you next time. And I'm going to go clean my hands. Again. Not as bad as the printers though.